So last time we learned about different types of mixtures, homogeneous versus heterogeneous. So in this section, we're going to talk about how to separate mixtures. Each different type of mixture means it requires a different way to separate it. It's going to be very different to separate a mixture that might be something like water, because H2O is a mixture, versus something like salt water. Those two different types of mixtures require two different methods of separation. Filtration is something we would normally get to use. You'll probably see this being used in one of our lab videos a little bit later. But in filtration, solid substances are separated from liquids and solutions. So you can see in this container, whatever this person is dumping out, it looks like some sort of orange precipitate, or remember a solid that forms in solution, is suspended in whatever liquid this is. Now, the only thing I would mention about this person's technique is that they're not wearing gloves. So we always want to make sure we're observing safety standards when we perform these labs. But they're using a very good technique here. And their technique is that they are putting this glass stirring rod down in front of the spout, and that guides the liquid down inside the filter paper. So we can see that as the smaller particles of water or whatever solvent this might be are falling through the funnel down into this flask, we can see that the orange particles that are a little bit larger are caught behind in the filter paper. So this separates based on size. The larger particles are held behind, the liquid falls through. You've also seen filtration, I'm sure, used in tea bags or coffee filters. Smaller particles move through, larger particles are held behind. Distillation. In distillation, it uses the differences in boiling points of substances to separate a homogeneous mixture into its components. So we can have two substances that look very similar to each other, two clear, colorless liquids in the same container. And how are we going to separate those? Filtration won't work because both of those are liquids with the same size particles, and both of them will fall right through the filter paper. So instead, we need to distill this sample or separate the liquids based on boiling points. So the way this works is we start with our Bunsen burner, heating up the water inside our boiling flask, or whatever sample of liquid we have in our boiling flask, but in this case, it's salt water. So what we do know is that water has a much lower boiling point than salt. So what's going to happen is as water approaches its boiling point, it's going to evaporate and it's going to move up inside this boiling flask. And usually at the top, there is some sort of thermometer, and that thermometer allows us to track the point at which we expect one liquid to be driven off of the other one. Now what we have here is what's called a condenser. Now in the condenser, we have cold water working its way in the tube at the bottom and then working its way up this chamber to then come out the top. Now, why doesn't the cold water come in the top and out the bottom? So this condenser is actually a chamber within a chamber. So what that looks like is we have two spouts, the in and the out. And then we have a chamber within that chamber and then another wall on the other side. And this is all what's happening within this chamber right here. So the way this works is we don't want water to come in the top because if it does, it'll just go straight out the bottom and it won't sufficiently cool that chamber. So instead, we send it in the bottom, and if we send it in the bottom, it will fill this area around that inner chamber. And then once it gets to the top, it will come out the top. So we want it in that chamber enough to sufficiently cool it. And the reason we want that chamber cooled is because we want the cool air to come out this way, to be able to reach that evaporated water, to cool it enough to the point where it will recondense and then drip all the way down the tube. And when it drips all the way down the tube, it will be collected into the receiving flask as pure water. So at the end, we're left with pure water in the receiving flask and the salt that has now been separated from the water behind in the boiling flask. So remember again, filtration will not work here because salt dissolves inside the water and both of those components would fall through the filter. Manual separation is probably the easiest one. In manual separation, the pieces are large enough to just pick out. So you can see here, it looks like maybe they're separating beans. If I put those in a filter, it wouldn't work. Distillation wouldn't work to separate those because one of them will not boil off of the other one. So in this case, it's easiest just to manually separate one from the other, or separate the brown beans from the red beans. And the last form is chromatography. Now, chromatography is a way to separate dyes. We can see a definite color separation in dyes like this. So it's separation based on attraction and size. And it doesn't just work with dyes, but this is just the most common way that we use chromatography. So we know that, for example, blue ink, green ink is made of blue and yellow pigments. So we can guess that this one here started as a sample of green ink. We also know that black is made of all of the colors of inks put together. So if we put a sample of black ink on this piece of paper, we would see black ink separate into blue and yellow and red colors. And you can even try this at home. You can take a coffee filter or even just a piece of paper, and you can cut your piece of paper so it's just a square like this, and then you can put a dot of ink down at the bottom. Now you want to be careful because you want to get some sort of cylinder, some sort of maybe cup that you can put this in, and that, like you see here, and then you want to put ink down at the bottom, but you don't want that ink to totally saturate that piece of paper that you're using, because as soon as you put it in there, if your ink dot is all the way down here, it will dissolve in the water and you won't see separation. What you want to happen is you want capillary action to pull the water up this sample. And when it does that, as long as you're using a water-soluble ink, something like Crayola markers are usually washable, which means water will separate their pigments, you want this to be water, something that will dissolve that ink. So as the water moves its way up this piece of filter paper, it will start to reach that ink, and then you will slowly see that ink start to separate. So what you should see when you do this, as we can see in the picture to the left, is the yellow is usually the first one to come off. And then maybe we can see that the pink is going, or the red is going to be just a little bit higher than that. And then we might see that the blue is just a little bit higher than that. So you should see some separation here. So it separates based on attraction. Is the ink spot attracted to whatever liquid you're using through capillary action to draw up that piece of paper? And then it's going to separate on size. So things that are larger tend to not move as fast. So whatever ink is closest to the bottom of the piece of paper, that's going to be your largest molecule. Whatever ink is able to move the furthest up the paper is going to be your smallest molecule. So you can try this at home and it will work. If you use something like a Sharpie, you're probably going to have to use something like rubbing alcohol to be able to separate that ink, because Sharpies are not water soluble.